Hello, friend. Welcome to Science for Sleep. Tonight, we're settling into something simple. Something many people have seen, perhaps even lit, without ever truly examining. A thin stick, a small cone, a quiet curl of smoke rising into still air. Incense feels familiar, gentle, almost ordinary. And yet, if someone paused you for a moment and asked what incense actually is, what it is made of, what rises from it as it burns, and what your body quietly does with that rising smoke, would an answer come easily? Most of us could describe the scent. Maybe the feeling in the room, the way the air seems softer once it begins to drift upward. But the physical process itself often remains unexamined, because what you see lifting into the air is not simply vapor, it is matter. Tiny solid pieces and scent molecules released by heat, carried upward by warm air. Incense is usually made from powdered wood, crushed plant resins, dried herbs, and a natural binder that holds everything together. These materials are pressed into a stick or shaped into a cone. When the tip is lit and the flame is gently blown out, it does not continue with an open flame. Instead, it begins to smolder. Smoldering simply means slow burning without a visible flame. At the glowing tip of that ember, temperatures can reach between 500 and 700 degrees Celsius. That is hotter than most home ovens. The heat is concentrated in a very small space, just a few millimeters wide, slowly moving down the incense as it burns. This heat breaks apart the solid plant material. Some parts turn into tiny airborne particles. Others become invisible scent molecules that float away from the ember. Together, they form what we call smoke. Smoke is not empty. It is a mixture of microscopic solid particles and warm gases suspended in air. The reason it rises is not because it weighs nothing. It rises because the air around the ember becomes warm. Warm air expands. When air expands, it becomes less dense. And less dense air drifts upward, carrying those particles with it. If you have ever watched incense closely, you may have noticed that the smoke first rises in a smooth, steady line. For a short distance, it moves in calm layers, almost like a thin ribbon. Then, gradually, it begins to curl and fold. The smooth rise becomes soft spirals and gentle waves. This change happens because the warm, rising air begins to mix with cooler air around it. As the two meet, small differences in speed and temperature create subtle shifts in movement. The patterns that form follow the same natural rules that shape clouds in the sky and currents in the ocean. The movement is never exactly the same twice, and yet it is never sharp or chaotic. It unfolds slowly, shaped by invisible currents. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is. Watching that thin column of smoke can feel almost hypnotic. The human visual system tends to settle when observing motion that is continuous and soft. Movement that changes gradually gives the mind something to follow without demanding effort. And all of this begins with something very simple, a small source of heat. Plant material transformed, air gently shifting, Incense often feels symbolic or spiritual or ceremonial. But before any of that, it is physics. It is heat changing solid matter into airborne particles. It is warm air rising. It is motion shaped by natural forces too small to see. And as we move slowly forward tonight, we'll continue to explore what else is happening in that quiet transformation. Not only in the air above the ember, but inside the body that breathes it in. Because incense is not only something you see, it is something your body understands even before your thoughts catch up. The smoke continues to rise, even after the question has softened and the ember has settled into its steady glow. For a few inches above the tip, the column appears almost perfectly smooth. It moves upward in a narrow line, as if it already knows the path it intends to take. This early stage of movement is called smooth flow. It simply means the air is traveling in neat layers, sliding past itself without much mixing. Warm air from the ember rises because it has expanded. When air warms, its molecules move slightly farther apart. That small expansion makes the air lighter than the cooler air around it. And lighter air drifts upward, carrying with it the tiny particles and scent molecules released from the burning plant material. At first, this upward motion is calm and layered. Scientists describe this kind of movement as laminar flow, which is just a term for smooth, orderly motion. Nothing is colliding abruptly. Nothing is folding back on itself yet. The column looks steady because, in this short stretch, it truly is. But as the smoke rises higher, something begins to change. The warm air column meets cooler, still air. The difference in temperature and speed between these two regions creates gentle instability. The smooth layers can no longer remain perfectly separate. Small ripples form at the edges. Those ripples grow into curls. The straight column bends and begins to twist. If you have ever watched carefully, you may have seen this moment. The smoke does not suddenly explode into chaos. Instead, it slowly transitions. A thin line becomes a ribbon. A ribbon becomes a spiral. A spiral breaks into drifting threads. These curling shapes follow the same physical rules that shape clouds in the sky and currents in the ocean. When two layers of fluid move at slightly different speeds, waves can form between them. Over time, those waves roll into soft loops and billows. This is why incense smoke feels familiar, even if you have never studied physics. The patterns echo movements your visual system has seen before. Steam rising from a cup, mist lifting from water, wind shaping a passing cloud. The motion is complex, but it unfolds gently. Scientists sometimes describe this shift from smooth flow to mixed flow as a transition from order to turbulence. Turbulence sounds dramatic, but here it is quiet. It simply means the air begins to mix more freely. Instead of traveling in clean layers, it folds and blends. Even in this mixing stage, the movement remains slow. The column rarely shoots upward sharply. It softens. It spreads. It drifts sideways when a small current in the room nudges it. Because the particles in incense smoke are extremely small, many of them remain suspended in the air for longer than we might expect. Some are less than 1,000th of a millimeter wide. Their light weight allows them to float and disperse gradually instead of falling straight down. What you are watching is not disappearance. It is diffusion. Diffusion simply means spreading out from a place of higher concentration to a place of lower concentration. The smoke thins not because it vanishes, but because its particles become more evenly distributed through the room. As this spreading happens, the visible column fades. The curls loosen, the loops stretch wider. Eventually, the smoke becomes so evenly dispersed that the eye can no longer detect its structure. But the motion never truly stops. Even in still air, countless tiny movements are happening. Air molecules are constantly shifting. Warm pockets cool. Cool pockets rise slightly as they mix. The room is never perfectly still, even when it feels quiet. And watching this gradual shift, from straight column to spiral to drifting haze, gives the mind something steady to follow. The motion does not demand interpretation. It does not ask for decisions. It simply unfolds. In the beginning, the smoke rises in a clean line. Then it begins to curl. Then it softens into the space around it. A small transformation of heat into motion. A visible reminder that air itself is always moving, even when we do not feel it. And as the smoke thins and spreads, something else begins to travel with it. Something far smaller than the particles you can see. Scent molecules. And those invisible travelers will carry the next part of this quiet story. As the visible smoke thins and spreads, something much smaller continues its journey through the air. Long before the curls fade from view, scent molecules are already moving outward in every direction. They are too small to see, far smaller than the tiny solid particles that make the smoke visible. And yet, these invisible molecules are the reason incense feels present, even after the air looks clear. Scent begins inside the solid material itself. Wood, resin, and dried herbs contain natural oils. These oils are made of tiny chemical structures that plants produce for their own survival. Some protect against insects. Some help seal wounds in bark. Some simply give the plant its distinct smell. When the glowing ember reaches a new section of incense, the heat does not only burn it. In many cases, it warms the material enough to release these oils into the air without fully destroying them. This is an important distinction. If a substance burns too hot with open flame, many of its scent molecules are destroyed. But incense is designed to smolder slowly. The heat is concentrated and controlled. That slower process allows many aromatic compounds to lift away intact. These compounds are often called volatile molecules. Volatile simply means they easily become airborne. At room temperature, they may sit quietly inside wood or resin. But when warmed, they gain enough energy to escape into the air as individual molecules. Each type of incense contains its own blend of these volatile compounds. Sandalwood releases molecules known for their warm, woody scent. Citrus peels contain limonene, which smells bright and fresh. Lavender holds linalool, often described as soft and floral. Though their names can sound complex, their behavior is simple. Heat loosens them, air carries them, and they spread outward from the source. Once airborne, these molecules move through a process called diffusion. Just like the visible smoke particles, they travel from areas where they are concentrated to areas where they are less concentrated. But because they are so small, they spread even more easily. Within seconds, scent molecules can move across a room. Within minutes, they may be present almost everywhere in the space. unlike the visible smoke, which thins as it disperses. Scent can remain noticeable even after the air looks clear. This is because the molecules responsible for smell are effective at extremely low concentrations. Only a tiny number need to reach your nose for you to detect them. Some of these molecules are light and evaporate quickly. Others are heavier and linger longer. This is why certain incense scents feel bright and immediate, while others feel deep and lasting. Perfumers sometimes describe scents in layers. A top note appears first and fades quickly. A middle note lasts longer. A base note lingers close to surfaces and remains after the brighter tones have softened. Incense behaves in a similar way. As the ember moves downward, it releases a steady stream of new molecules. The room slowly fills with overlapping waves of scent, each at a slightly different stage of dispersal. Even after the stick has finished burning, some molecules may cling gently to fabrics or walls. Others continue to drift in the air until ventilation gradually replaces them with fresh air. And all of this movement happens without sound. Tiny particles rising, microscopic molecules spreading, air quietly shifting from one state to another. What appears to be a simple scent in a room is actually the result of countless individual molecules moving, separating, colliding, and dispersing. Each molecule carries a shape. That shape determines how it will interact with the body. But before we consider what happens inside you when you breathe them in, it is enough to recognize this. Incense does not create scent from nothing. It releases what was already there. Heat unlocks stored molecules, air carries them outward, and the invisible becomes gently present. The visible smoke may fade, but the chemistry continues, quietly, all around you. Those invisible molecules continue drifting through the air until some of them meet the entrance to the body. Each time you inhale, air moves through the nose and into narrow passageways lined with delicate tissue. Near the top of the nasal cavity, tucked slightly out of the direct path of airflow, there is a small patch of specialized cells designed specifically to detect smell. This area is called the olfactory epithelium. Olfactory simply means related to smell. Epithelium means a thin layer of cells that lines a surface. So the olfactory epithelium is, quite simply, the smell tissue. It is small. In humans, it covers only a few square centimeters. And yet, within that small space are millions of receptor cells. Each receptor cell carries tiny hair-like structures that extend into a thin layer of mucus. When scent molecules enter the nose, they dissolve into that moisture and make contact with these receptors. Every scent molecule has a particular shape, and every receptor is tuned to recognize certain shapes more easily than others. When a molecule fits well enough, it binds to the receptor, like a key resting in a lock. This binding does not create scent on its own. It creates a signal. Inside the receptor cell, the binding triggers a chain reaction. The cell changes its electrical state. That change becomes a tiny electrical impulse. And that impulse travels along a nerve fiber toward the brain. This is where smell becomes unique among the senses. Most sensory information, sight, sound, touch, travels first to a structure deep in the brain called the thalamus. The thalamus acts like a sorting center. It receives incoming signals, organizes them, and sends them onward to other parts of the brain for further processing. smell takes a different route. Signals from the olfactory receptors travel directly to a region called the olfactory bulb, which sits just above the nasal cavity. From there, information moves quickly into areas involved in emotion and memory, including the amygdala and the hippocampus. This means scent can reach emotional centers of the brain without first passing through the thalamus. It does not wait in line. That direct connection helps explain why certain scents feel immediate. The body can respond before the conscious mind fully identifies what it is smelling. If you have ever experienced a scent that suddenly shifted your mood, or brought back a distant memory before you could name it, this pathway is part of the reason why. The olfactory bulb itself acts like a pattern detector. It receives signals from many different receptor types and organizes them into recognizable combinations. A single scent is rarely made of one molecule alone. It is usually a blend. The brain interprets that blend as a distinct smell. When incense burns, dozens of different scent molecules may be released at once. As they reach the receptors in the nose, different patterns of activation occur. The olfactory bulb maps these patterns and sends them deeper into the brain. All of this happens in fractions of a second. Air moves inward. Molecules bind. Electrical signals fire. Emotion-related regions activate. And yet, the process feels effortless. Breathing does not require conscious effort most of the time. Smelling does not require instruction. The body is designed to detect airborne chemicals as part of survival. In earlier human environments, scent could signal food, fire, danger, or safety. Today, when incense releases its molecules into the air, the same ancient detection system responds. The receptors do not know whether the scent comes from a forest, a kitchen, or a quiet room at night. They simply respond to molecular shapes. As you sit in a space scented by incense, each inhale becomes part of a repeating cycle. New molecules arrive. Receptors bind them. Signals travel. The brain integrates. The smoke you can see has mostly faded by now, but the invisible chemistry continues. Tiny keys meeting tiny locks. Signals moving upward through delicate nerve pathways. A steady conversation between air and body. And in that quiet exchange, scent becomes something more than atmosphere. It becomes experience. Once those signals leave the olfactory bulb, they travel deeper into regions of the brain that shape feeling and memory. Two of these regions are especially important. One is the amygdala, which helps the body process emotional meaning. The other is the hippocampus, which plays a key role in forming and recalling memories. Because scent pathways connect directly to these areas, smell often feels emotional before it feels descriptive. You may notice this in small ways. A certain scent can feel warm before you think the word warm. It can feel familiar before you identify why. It can soften the body before you consciously decide it is pleasant. This happens because the brain does not wait for a detailed analysis. The signal arrives, and emotional systems respond quickly. In most senses, there is a clearer separation between detection and interpretation. You see something, you name it. Then you decide how you feel about it. With scent, that order can blur. The feeling can come first. Researchers sometimes refer to a phenomenon where a smell brings back a vivid memory with unusual clarity. You might catch a hint of wood smoke and suddenly recall a specific evening from years ago. Not as a story you are telling yourself, but as a full sensory impression. This happens because the hippocampus, which helps store contextual memories, is closely connected to the olfactory system. When a scent is first experienced, the brain can link it with the surrounding environment, the lighting, the temperature, the emotional tone of the moment. Later, when the same scent appears again, that network of stored details can reactivate. It does not always happen dramatically. Often, it is subtle. A room scented with incense may begin to feel calmer simply because the brain associates that scent with previous quiet evenings. The more often the scent appears during relaxed states, the stronger that association can become. Over time, lighting incense may act as a cue. The brain learns that this scent often appears during periods of rest. The body begins to anticipate what usually follows. Muscles loosen slightly, breathing slows. The nervous system shifts toward a calmer mode. This is not magic, it is learning. The amygdala helps evaluate whether a stimulus feels safe or concerning. If incense has been repeatedly paired with peaceful environments, the amygdala may interpret its scent as neutral or comforting. That interpretation can influence the rest of the nervous system. Because the olfactory pathway bypasses the thalamus, as we discussed earlier, the emotional centers receive the signal quickly. There is less delay between detection and response. In everyday life, this rapid connection between smell and emotion once served survival. The scent of smoke could signal fire. The smell of spoiled food could signal danger. The body needed to react before detailed reasoning took place. Today, when incense releases warm, woody, or resinous molecules into the air, that same system responds, but in a gentler context. Instead of danger, the scent may signal ritual, quiet, or routine. There is also evidence that certain aromatic compounds can influence brain activity directly. Some plant-derived molecules have been studied for their ability to interact with neurotransmitter systems linked to relaxation. While the effects are usually mild, they can contribute to the overall experience. But even without focusing on specific compounds, the simple pairing of scent with calm moments can shape emotional response. Think of it like a repeated pattern. Evening arrives. The room grows quieter. Incense is lit. The scent fills the air. The body relaxes. Repeat this enough times, and the scent alone can begin to suggest what comes next. In this way, incense becomes more than airborne chemistry. It becomes a marker, a signal that the pace is slowing, a reminder that the day is softening, a cue that attention can narrow and settle. The smoke that once rose in a smooth line has mostly dispersed now. The particles have spread thinly through the room. The visible motion has faded, but the scent remains. Invisible molecules continue binding to receptors. Signals continue traveling through ancient neural pathways. Emotional centers continue integrating. The air feels different, and the difference is not only in the room. It is in the way the body interprets what it is breathing. Scent, arriving quietly, can shift emotional tone without demanding effort. It can bring memory closer. It can soften the edge of alertness. And as those pathways continue to activate gently, attention itself begins to change. Not sharply, not suddenly, just enough to notice that the space feels a little more contained. a little more focused, a little more still. As scent continues to arrive with each breath, something subtle begins to shift in the way attention is distributed. When a new smell enters the air, especially one that is noticeable but not overwhelming, the body often responds with a slightly deeper inhale. It is a small adjustment. Air draws in more fully. The chest expands a little farther. The rhythm of breathing becomes just a touch more deliberate. This gentle emphasis on inhalation brings awareness closer to the breath itself. Breathing is one of the few body processes that can run automatically or be observed consciously. When scent becomes present, even softly, it encourages that observation. Each inhale carries new information. Each exhale releases it. As attention moves toward breathing, other sensory inputs begin to soften at the edges. Visual details in the room remain, but they feel less urgent. Background sounds continue, but they seem more distant. The brain does not stop processing them, but it begins to reduce how much importance it assigns to them. The nervous system is constantly scanning the environment for change. This scanning helps detect movement, unexpected sounds, or new sensations. It is part of staying alert. But when a steady scent fills the air, and nothing about it signals danger, the scanning process can ease slightly. The environment feels more predictable. And predictability reduces the need for constant checking. Imagine the brain as receiving signals from many channels at once. Sight, sound, touch, temperature, scent, internal sensations like heartbeat and breath. When many signals compete equally for attention, the experience can feel busy. That busyness is sometimes described as mental noise. Mental noise simply means many sensory inputs asking for attention at the same time. When incense becomes noticeable, scent can take a slightly stronger position among those channels. Not loudly, just enough to become a steady background presence. Because scent is continuous and does not flash or change quickly, it gives attention something stable to rest on. It does not demand interpretation the way a sudden sound might. It does not shift rapidly like moving images. It remains. And as attention settles toward this steady sensory input, the number of competing signals that feel important can decrease. The room has not changed dramatically, but the way it is being processed has. Visual distractions feel softer because they are no longer the primary focus. Sounds blend into the background because they are not being scanned for meaning as intensely. This shift can feel like a narrowing of attention, not in a tight or pressured way, more like a gentle focusing. Instead of attention spreading outward in many directions, it draws inward slightly, following the rhythm of breathing and scent. Breath in, scent detected. Breath out. Each cycle repeats. When fewer signals feel urgent, the nervous system can move toward a calmer state. Heart rate may slow slightly. Muscles may loosen. Thoughts may space out a bit more. None of this requires effort. It is simply what happens when the environment feels steady and the body recognizes that steadiness. The smoke has long since dispersed into thin air. The visible column no longer demands attention, but the invisible molecules remain present, arriving softly with each inhale. The scent does not flicker. It does not pulse. It does not demand. It creates a stable sensory field. And within that field, attention has less reason to scatter. The brain reduces scanning for new input because nothing new is appearing. The scent remains consistent. The room remains quiet. The signals become fewer and more predictable. Fewer signals, less mental noise, a slightly quieter internal landscape. This is not caused by a single dramatic effect. It is the result of small adjustments layered together. Breathing slows just a little. Scanning decreases just a little. Attention narrows just a little. And together, those small shifts can make the space feel contained, more settled, more defined. Incense does not force the mind to be still. It gives it fewer reasons to wander. When attention narrows and the environment begins to feel steady, another layer quietly strengthens the effect. Ritual. A ritual does not have to be complex. It can be as simple as repeating the same small action at roughly the same time each day. Over time, the brain begins to recognize patterns. And when patterns repeat without negative outcomes, the nervous system learns that they are safe. Lighting incense can become one of those patterns. The hand reaches for the stick. A match is struck. The tip glows briefly with flame. The flame is blown out. A thin line of smoke begins to rise. If this sequence happens regularly, perhaps in the evening, perhaps before reading, perhaps before rest, the brain begins to connect the action with what usually follows. The nervous system is built to predict. It constantly tries to anticipate what comes next. Prediction reduces effort. When the brain can guess what is about to happen, it does not need to remain in a high alert state. Repeated actions teach the brain what to expect. If lighting incense is followed by quiet time, softer light, slower movement, or sleep, then the scent becomes part of that chain. It becomes an early signal. Over days or weeks, the association strengthens. The moment the ember begins to glow, the body may begin to shift slightly toward relaxation, even before you consciously decide to relax. This is a form of learning. The brain links the sensory cue with a state change. It is similar to how certain songs can signal the start of a workout, or how a familiar chair can signal reading time. The scent becomes a marker of transition. Stress hormones also respond to predictability. Stress hormones are chemicals released by the body during challenge or uncertainty. One of the most well-known is cortisol. Cortisol helps mobilize energy and sharpen focus when something demands attention. But when routines are familiar and outcomes are known, the need for elevated stress hormones decreases. Studies show that predictable environments tend to lower baseline stress levels compared to unpredictable ones. The brain feels less need to scan for threat when it recognizes a pattern. Lighting incense at the same time each evening can gradually signal that the day's demands are ending. The action itself is small, but its repetition matters. The body notices consistency. Consistency tells the nervous system that the environment is stable. Stable environments require less vigilance. Less vigilance means fewer stress signals. Over time, the relaxation response can arrive more quickly. The scent does not need to work harder. The body has learned what it usually means. This is why ritual often feels comforting. It narrows uncertainty. It frames time. It separates one part of the day from another. When incense becomes part of that rhythm, it anchors the transition. Morning has its cues, afternoon has its pace, evening develops its own signals. The ember glowing at dusk can become one of them. And because scent connects directly to emotional centers of the brain, as we explored earlier, the association can feel deep and immediate. The smoke rises, the scent spreads. The body remembers what usually follows. Muscles soften slightly. Breathing steadies. Attention turns inward. This does not happen in a dramatic wave. It unfolds gradually, strengthened by repetition. The more often incense is paired with calm moments, the more reliably it may evoke that state. Not because of superstition, not because of belief, but because the nervous system adapts to repeated pairings. Ritual creates expectation. Expectation reduces uncertainty. Reduced uncertainty lowers stress signals, and lowered stress signals allow the body to rest more easily. The scent drifting through the room is now more than chemistry. It is part of a familiar sequence. The hand, the match, the ember, the smoke. A simple pattern, repeated enough times to become meaningful. And in that meaning, the body finds permission to soften a little sooner than it might have otherwise. Long before incense became part of quiet rooms at the end of the day, it moved through ancient cities, temples, and trade routes. Thousands of years ago, people were already discovering that certain resins and woods released powerful scents when warmed. These materials were not common everywhere. Many came from specific trees that grew only in certain climates. Harvesting them required patience and care. In ancient Egypt, blended resins were burned at particular times of day. One mixture, known historically as kaifi, was often used in the evening. It combined crushed plant materials, honey, wine, and aromatic resins. The smoke was believed to prepare the space for night. As the sun lowered and shadows lengthened along stone walls, resin smoke would rise slowly through temple air. The scent marked a shift in time. Day activity softened. Night approached. In India, incense became woven into daily devotional practices. Sticks made from powdered wood and natural binders were shaped by hand. When lit, they marked moments of prayer, meditation, or transition. The scent filled homes and temples alike. In China, incense was used not only in spiritual settings, but also in scholarly spaces. It was burned during study and reflection. Some households even used incense as a subtle measure of time. Carefully shaped coils could burn for hours at a steady pace, offering a quiet visual and sensory clock. In Japan, the appreciation of incense developed into a refined art. There, people practiced what is often translated as listening to incense. Instead of simply smelling it, participants would sit in silence and focus carefully on subtle differences in scent. Small pieces of aromatic wood were gently heated, not burned with flame, to release their fragrance more purely. This practice slowed attention. It encouraged patience. It turned scent into something to be observed closely, rather than rushed past. Across the Arabian Peninsula, valuable resins such as frankincense and myrrh were transported along long desert routes. Caravans carried them from tree-growing regions to distant cities. These journeys could take months. The materials were light in weight, but high in value, because they were rare and widely desired. Temples, ceremonies, and households across continents used these resins to transform the atmosphere of a space. It is important to notice something here. Across cultures separated by distance and language, people independently discovered that warming plant materials could change how a room felt. The reasons they described may have differed. Some spoke in spiritual terms, others in medicinal language, but the physical process was the same. Heat released aromatic molecules, smoke marked the air, scent shifted perception. In many cases, incense was burned at moments of transition, morning to midday, day to night, before prayer, before rest. The timing mattered as much as the material itself, and that repeated timing strengthened associations, much like the ritual we discussed earlier. When Egyptian priests burned resin at dusk, it signaled the closing of one part of the day. When incense drifted through a scholar's study in China, it framed a period of focused attention. When Japanese practitioners gathered to quietly observe subtle differences in scent, it structured a moment of deliberate slowness. Even the trade of incense reflects something about human attention. People were willing to transport these materials across long distances because they valued what the scent did to a space. The smoke altered atmosphere in a way that was visible, tangible, and memorable. Incense was not only fragrance, it was environmental change. A room without incense and a room with incense feel measurably different, not only in scent, but in the way attention behaves within them. And so, across centuries, across deserts and oceans, incense moved from forest trees to carved temples, from market stalls to quiet homes. Resin hardened on bark. Wood was harvested and dried. Powdered materials were shaped into sticks and cones. The same small ember we see today once glowed in ancient spaces lit by oil lamps and sunlight. The physics was the same. The chemistry was the same. And the human nervous system responding to scent was the same. What changes are the stories we tell about it. But beneath the stories, the process remains simple. Plant material warmed, molecules released, air gently transformed. And in that transformation, people across time found a way to mark moments, to soften the edges of the day, and to give scent a role in shaping experience. Among the many materials that have been burned across centuries, one resin appears again and again: frankincense. It comes from trees in the Boswellia family, which grow in dry, rocky regions of the Middle East and parts of Africa. The trees do not release their resin automatically. The bark must be gently cut. When the tree is wounded, it responds by producing a thick, milky sap that slowly hardens in the open air. Over time, this sap forms small tear-shaped droplets along the bark. Once hardened, these resin tears can be collected. They look almost like pale amber stones. When warmed, they soften and release a distinct scent, woody, slightly sweet, and gently sharp at the edges. Like all incense materials, frankincense releases its aroma because heat loosens molecules that were stored inside the hardened resin. But frankincense contains a compound that has drawn scientific interest in recent years. One of its natural components is called incensol acetate. The name sounds technical, but what matters is what it appears to do. In laboratory studies with animals, incensol acetate has been shown to activate certain channels in the brain that respond to warmth. These channels are part of a family of receptors that detect changes in temperature and internal state. You can think of them as tiny sensors that respond to heat-like signals. When activated, these warmth-sensitive channels can influence areas of the brain involved in emotion and mood regulation. This does not mean frankincense forces calm onto the body. The effects observed in studies are subtle, but it suggests that certain plant-derived molecules may interact directly with the nervous system in measurable ways. In animal research, exposure to incensol acetate has been associated with behaviors that suggest reduced anxiety and mild antidepressant-like effects. Scientists believe this may be linked to the activation of these warmth-sensitive channels in emotional regions of the brain. To understand this more simply, imagine that the brain has tiny switches that respond to internal signals. Some respond to light, some to sound, some to temperature. When a compound activates a warmth-sensitive channel, it may gently influence how certain emotional circuits behave. It is not a dramatic shift. It is more like a nudge. Frankincense also contains other aromatic compounds that contribute to its scent profile. Some are lighter and rise quickly when heated. Others are heavier and linger close to surfaces. When placed on a charcoal disc or inside a small burner, frankincense does not ignite into flame immediately. Instead, it often melts first. The resin softens, bubbles slightly, and then begins to release visible smoke. This melting stage changes how the scent is released. Because the resin liquefies before fully combusting, aromatic molecules can vaporize from the surface before being broken apart by high heat. The result is often a rich, layered scent that unfolds gradually. Historically, frankincense was valued not only for its fragrance, but also for its preservative properties. Resin has natural antimicrobial characteristics, which may have contributed to its use in certain rituals and practices. But even without focusing on preservation, the simple act of warming hardened tree sap produces a transformation that is both visible and fragrant. A solid tear becomes softened. Softened resin releases scent. Scent drifts outward. As we explored earlier, those scent molecules travel through the nose and into the brain's emotional centers. If a compound like incensol acetate interacts with warmth-sensitive channels there, it adds another layer to the experience. The effect remains gentle. It is part of a larger system involving breathing, attention, memory, and ritual. Frankincense does not act alone. It becomes part of the environment, part of the pattern of inhalation, part of the sequence of evening light and slower movement. And when that sequence repeats over time, the resin's scent may come to signal safety and familiarity. What began as hardened sap protecting a tree wound now becomes airborne chemistry influencing perception. From bark to ember, from resin to vapor, from molecule to neural signal. The transformation is quiet, but the pathway, from tree to breath to brain, is precise. And in that precision, frankincense offers one example of how plant materials can interact with the human nervous system in ways both ancient and measurable. Alongside frankincense, another resin has traveled the same ancient paths. Myrrh. It comes from trees in the Commiphora family, which grow in dry, sunlit regions similar to those that produce frankincense. Like frankincense, myrrh begins as sap released, when the bark of the tree is gently cut. The sap seeps outward and slowly hardens in the open air. But myrrh looks and behaves a little differently. Its hardened resin tends to be darker, more reddish-brown, and often slightly irregular in shape. When broken apart, it can appear crumbly or grainy, and when warmed, its scent is deeper, more earthy, sometimes slightly bitter. If frankincense feels bright and lifted, myrrh often feels grounded. The difference begins with chemistry. Myrrh contains a different blend of aromatic compounds, including molecules known for their heavier scent profile. These molecules tend to evaporate more slowly. Because they are slightly larger or less volatile, they do not rise as quickly into the air. This changes how the scent unfolds. When placed on heat, myrrh often melts before it begins to smoke. The hardened resin softens and turns glossy. Small bubbles may form on its surface as heat loosens the internal compounds. During this melting stage, aromatic molecules escape gradually. Only after this softening does visible smoke begin to form more fully. This sequence, melt first, then release, creates a layered effect. The scent builds slowly, thickening the air in a steady way, rather than appearing all at once. Because some of myrrh's aromatic molecules are heavier, they can linger closer to surfaces. Fabrics, wood, and walls may retain faint traces of the scent even after the smoke itself fades. This lingering quality contributes to its perception as a base note. In fragrance language, a base note is the part of a scent that remains longest after brighter elements have softened. Myrrh's earthy tone often feels steady rather than sharp. The scent does not flash and disappear. It settles. Historically, myrrh has been used not only for fragrance, but also for preservation. Resins naturally help seal and protect plant wounds, and some of the same chemical properties that defend trees from microbes have antimicrobial effects. In ancient practices, myrrh was sometimes used in preservation rituals. The resin's natural compounds helped reduce bacterial growth in certain contexts. But even without focusing on those historical uses, the physical behavior of myrrh when heated remains central to understanding its effect. A dark, hardened resin softens, heat loosens stored compounds. Scent rises slowly. Unlike some woods that burn steadily along a stick, loose myrrh pieces require an external heat source, such as charcoal. The charcoal provides consistent warmth, allowing the resin to release aroma without needing an open flame. This controlled heating mirrors what we have seen before. When heat is steady rather than explosive, aromatic molecules are more likely to vaporize intact. The room fills gradually. The scent does not demand attention. It spreads outward in a quiet expansion. As the molecules disperse, they enter the same olfactory pathways we explored earlier. Receptors bind them. Signals travel. Emotional centers integrate. But because myrrh's scent profile is often described as deeper or heavier, it can influence perception in a slightly different way. Where brighter scents may feel energizing, heavier base notes can feel stabilizing. The body does not interpret the scent as sharp or alerting. Instead, it often feels grounded. This does not mean myrrh forces relaxation. The effect remains part of a larger system involving ritual, memory, and breathing. But its slower release and lingering presence create a steady sensory field. As the resin continues to warm, The glossy surface gradually darkens. The scent becomes more diffuse. The charcoal beneath cools. Eventually, what remains is a small, hardened fragment once again, altered but recognizable. From tree wound to hardened resin, from resin to softened melt, from melt to drifting scent. Myrrh follows the same fundamental path as other incense materials, yet its pace and weight give it a slightly different character. And in that difference, it shows how small variations in chemistry can shape how a space feels. The air carries its molecules quietly, and the body responds, just as it has for thousands of years. Where resins begin as hardened sap from wounded bark, sandalwood begins as something denser and more solid. It comes from the heartwood of certain trees, most famously those in the santalum family. The heartwood is the dense inner core of the tree. Over many years, this inner wood develops a high concentration of aromatic oils. Unlike leaves or bark, which may release scent quickly and fade, heartwood stores its fragrance deep within tightly packed fibers. When sandalwood is carved, ground, or shaped into incense sticks, those oils remain trapped inside the wood structure. Heat is required to release them. Because sandalwood is dense, it burns more slowly than many lighter plant materials. The ember moves at a steady pace, consuming the wood gradually. This slow burn is not accidental. It reflects the physical structure of the material itself. Dense wood allows oxygen to penetrate more slowly, and slower oxygen flow supports smoldering rather than open flame. As the ember reaches a new section of sandalwood, heat loosens the aromatic oils stored within. One of the primary scent compounds released is called santalol. The name may sound technical, but it refers to the specific molecule largely responsible for sandalwood's creamy, warm aroma. When santalol becomes airborne and enters the nose, it follows the same pathway we have already explored. It dissolves into the mucus lining the olfactory tissue. It binds to receptors. Signals travel toward emotional centers of the brain. But sandalwood has also been studied for its measurable effects on the body. Some small studies suggest that inhaling sandalwood aroma can reduce heart rate slightly and increase alpha brainwave activity. Alpha waves are patterns of electrical activity in the brain, often associated with relaxed wakefulness. Relaxed wakefulness is the state between alertness and sleep. It is the feeling of being present, but not tense. Focused, but not strained. If alpha wave activity increases gently, it can reflect that the brain is settling into that softer state. Research in this area remains modest, and effects are usually subtle. But the findings align with many people's subjective experiences. Sandalwood is often described as calming, grounding, or centering. Part of this perception may come from chemistry. Part may come from association and ritual. And part may come from how its scent unfolds over time. Unlike brighter aromas that appear quickly and fade, sandalwood tends to build slowly. Because the wood burns gradually, the release of scent molecules remains steady. The air does not fill with a sudden wave. Instead, the fragrance thickens in layers. If you observe a sandalwood stick burning, you may notice the ember glowing steadily without flare. The smoke is often fine and even. The scent spreads without sharp edges. This steadiness can contribute to the narrowing of attention we discussed earlier. There are no abrupt changes to track, no rapid spikes of sensation, just continuity. And continuity reduces the need for scanning. Historically, sandalwood has been valued in many cultures, especially in India and parts of Southeast Asia. The wood has been carved into beads, ground into paste, and shaped into incense sticks. Its fragrance has been linked to meditation, prayer, and quiet reflection. But beneath cultural meaning lies physical behavior. Dense hardwood, stored aromatic oils, slow oxygen-limited burn, gradual release of santalol. When heat reaches the wood, molecules lift into the air. Those molecules travel inward with each breath. Receptors bind them. Signals move through the olfactory bulb toward emotional centers. If heart rate lowers slightly, if breathing deepens subtly, if alpha brain waves increase modestly, the changes happen without effort. The body does not need instruction. It responds to the steady sensory field created by scent, ritual, and slow combustion. And because sandalwood burns at a measured pace, it also becomes a quiet measure of time. The ember moves millimeter by millimeter. The ash lengthens. The room fills gradually. What began as dense, silent hardwood becomes invisible chemistry shaping perception. And like the resins before it, sandalwood demonstrates how plant materials, warmed carefully, can influence the environment not through force, but through consistency. The scent lingers, the breath steadies, the space feels held, not because anything dramatic has happened, but because small physical processes, heat, release, diffusion, have unfolded slowly enough for the body to follow. In Japan, the appreciation of incense developed into something especially quiet and deliberate. There is a practice sometimes translated as listening to incense. The phrase may sound unusual at first. Incense does not make sound, but the word listening is used to describe a kind of careful, respectful attention. Instead of casually smelling a fragrance as it passes through the air, participants sit in stillness and notice subtle differences in scent. Small pieces of aromatic wood are gently heated, often without direct flame, so that the fragrance rises cleanly and slowly. The room remains quiet. Each person takes a measured breath, allowing the scent to move inward. There is no rush to identify it quickly. The goal is not performance. It is awareness. Because the fragrance is released gently, the scent may change slightly from moment to moment. A warmer note may appear first. A softer undertone may follow. Participants are invited to notice these layers with patience. This kind of focused observation naturally slows breathing. When attention rests on something subtle, inhalation tends to deepen slightly. Exhalation lengthens. The body mirrors the pace of the scent itself. In many versions of this practice, only a few small inhalations are taken. Then the piece of incense is passed to the next person. Silence continues. Listening to incense becomes an exercise in restraint. Instead of filling the air with strong smoke, the fragrance is offered lightly. Instead of talking about it immediately, participants sit with it. Attention narrows gently toward sensation. Patience builds through repetition. Subtle differences become easier to notice over time. What once felt indistinguishable begins to reveal small contrasts. A woody note may feel dry rather than sweet. A resin may feel bright rather than deep. This training of attention does not rely on effortful concentration. It relies on steadiness. Scent becomes the anchor. Breath becomes the rhythm. Time slows to match the pace of observation. In this way, incense moves beyond simple fragrance. It becomes a tool for shaping attention. The ember glows softly. A thin thread of aroma rises. The room remains still. And within that stillness, breathing and perception align. As incense continues to burn in different spaces, it is also important to consider balance. Burning any plant material creates tiny particles in the air. These particles are often too small to see individually, but together they form smoke. Some are large enough to fall quickly. Others are small enough to remain suspended longer. Ventilation plays a simple but meaningful role here. When a room has gentle airflow, a slightly open window, natural air exchange, or moderate space, particles disperse more evenly. Fresh air replaces older air gradually. The environment remains balanced. Natural incense materials, such as pure woods and resins, tend to release scent through controlled smoldering. Synthetic fragrances may contain additional compounds that behave differently when heated. This does not mean one must avoid incense entirely. It simply means moderation matters. A small stick in a ventilated space behaves differently from multiple sticks in a sealed room. The goal is not intensity, it is atmosphere. When used gently, incense creates a layered sensory field without overwhelming the air. The ember itself explains part of why incense behaves this way. Incense does not usually burn with an open flame once it is lit. The flame is extinguished, leaving behind a glowing coal at the tip. This coal receives oxygen slowly from the surrounding air. Because oxygen reaches the material gradually, combustion remains controlled. The ember moves down the stick at a steady pace, often only 1 to 2 centimeters per minute. This slow movement becomes a quiet measure of time. You can see how much has burned. You can estimate how long it has been glowing. The length of ash tells a story of minutes passing. Nothing rushes. The burn rate remains steady because the structure of the stick and the flow of oxygen regulate the heat. Dense materials slow it further. Looser powders allow it to move slightly faster. Watching the ember travel downward gives the room a gentle temporal rhythm. And above that ember, the smoke continues to curl. The curling patterns follow the same natural movement rules seen in clouds and water currents. Warm air rising meets cooler air resting. Small differences in speed create rolling shapes. The movement is never identical, but it is never chaotic. Your visual system recognizes this kind of motion as safe. Scientists sometimes use the phrase soft fascination to describe attention that is held without strain. Soft fascination occurs when something is interesting enough to observe, but not demanding enough to exhaust you. Watching smoke fits this description. The curls change slowly. The patterns unfold without sharp edges. Attention follows the movement effortlessly. There is no puzzle to solve, no sudden shifts to interpret, just fluid motion. As scent fills the air, breathing often deepens slightly. Deeper breathing activates calming pathways in the nervous system. One of these pathways runs along the vagus nerve, which helps regulate heart rate and digestion. Slower breathing can gently reduce heart rate. Muscles may loosen. Shoulders may drop slightly without conscious effort. These changes are small, but small changes layered together become noticeable. When the body relaxes, something else shifts as well. The brain keeps an internal sense of time, often described as an internal clock. This clock is not a ticking sound. It is a network of signals that estimate how much time has passed based on attention and arousal. When you feel alert or stressed, the internal clock can seem to tick quickly. Moments feel shorter. Time feels urgent. When you feel calm, the clock appears to slow. Moments feel longer. Without urgency, time stretches. Studies show that relaxed states often lead people to underestimate how much time has passed. A quiet half hour can feel shorter than it truly was, or a brief moment of calm can feel spacious. Incense, through scent, ritual, and steady visual motion, can contribute to this gentle slowing. The ember moves slowly. Breathing steadies. Attention narrows. The internal clock softens its pace. And in that softened pace, the room feels larger than its walls. Not because it has changed in size, but because time within it has stretched. As incense continues to shape the atmosphere of a room, it is helpful to pause and look at something simple and practical. Burning plant material changes the air. This is not dramatic. It is physical. When wood, resin, or herbs smolder, they release tiny particles along with scent molecules. Some of these particles are visible as smoke. Others are too small to see, but still present. These particles are often measured in micrometers, which are very small units of length. A human hair is roughly 70 micrometers wide. Many smoke particles are far smaller than that. Because they are light, they can remain suspended in the air for a period of time before settling or dispersing. This does not mean incense is harmful in every situation. It simply means that balance matters. Air in any room is always changing. Fresh air moves in. Used air moves out. The more airflow present, the more quickly particles and gases are replaced. Ventilation can be as simple as a slightly open window, a gentle draft, or a room that naturally exchanges air with surrounding spaces. When air circulates gradually, particles thin out more quickly. The atmosphere stays lighter. In a completely sealed room with little airflow, smoke particles can accumulate more easily. The scent may feel stronger. The air may feel thicker. Moderation makes a difference. A single stick burning occasionally in a ventilated space behaves very differently from multiple sticks burning continuously in a closed environment. The goal of incense has traditionally been to shape atmosphere, not to overwhelm it. Natural ingredients also influence how the air behaves. Incense made from pure woods, resins, and simple binders tends to release plant-derived compounds that have been part of human environments for centuries. Synthetic fragrances, by contrast, are laboratory-created scent molecules. When heated, they may behave differently. This does not automatically make one safe and the other unsafe. But it does mean the composition of the material matters. High-quality incense often lists its ingredients clearly. Lower quality products may include fillers or artificial scent enhancers that burn more harshly. Again, this is not a cause for alarm. It is simply part of understanding the process. When plant material smolders, carbon dioxide is produced. Small amounts of carbon monoxide can also form in low oxygen conditions. In open, ventilated spaces, these gases disperse quickly. In enclosed spaces without airflow, they can accumulate. This is why traditional incense practices often take place in rooms with natural ventilation or in spaces large enough for air to circulate gently. The physics remains the same. Heat releases particles and gases. Air carries them outward. Ventilation replaces older air with new. The intention behind incense has rarely been to saturate a room to its limit. It has usually been to introduce a subtle shift, a thin ribbon of smoke, a soft fragrance, a gradual transformation. When used in moderation, the concentration of particles in the air stays relatively low. The scent remains noticeable without becoming heavy. The body is sensitive to air quality. If the air feels thick or irritating, the nose and throat respond. That feedback helps guide use. Balanced use respects both atmosphere and physiology. A small ember in a well-ventilated room creates a different experience than strong smoke in still air. Understanding this does not remove the calm from incense. It deepens it. Because calm often includes awareness. Awareness of breath, awareness of scent, awareness of the air itself. Incense changes the air in measurable ways. The change can be gentle and intentional. When air flows freely, when materials are chosen carefully, and when use remains moderate, the transformation remains subtle. A quiet adjustment to the atmosphere, not an excess. Just enough to notice. Just enough to soften the edges of the room without overwhelming it. And within that balance, the ember continues its slow descent, shaping both scent and space with steady, controlled warmth. Beneath the rising smoke and drifting scent, something steady continues at the source. The ember. Incense does not behave like a candle. A candle holds a visible flame that feeds on liquid wax, drawn upward through a wick. Incense, once lit and blown out, leaves behind only a small glowing coal at its tip. That glow is enough. The ember receives oxygen slowly from the surrounding air. Oxygen is necessary for combustion, which is simply the chemical reaction between fuel and oxygen that releases heat. But in incense, the oxygen supply is limited. The material is packed tightly, and the surface area exposed to air is small. Because oxygen reaches the burning point gradually, the combustion remains controlled. There is no bright flame racing downward. Instead, the ember moves millimeter by millimeter. This process is called smoldering. Smoldering means slow burning without flame. It happens at lower temperatures than open fire, but still high enough to break down plant material into smaller compounds. Earlier, we noted that the glowing tip can reach temperatures between 500 and 700 degrees Celsius. That heat is concentrated in a very small zone. Behind the ember, ash forms. Ash is what remains after most of the combustible material has reacted. It is lighter in color and more fragile than the unburned stick. If you gently tap incense, the ash may fall away in a soft line, revealing the darker core beneath. The rate at which the ember moves depends on several factors. The density of the material plays a role. Tightly packed powders burn more slowly because air penetrates less easily. Looser materials may allow slightly faster movement. Humidity in the room can also influence the burn rate. Moist air may cool the ember slightly. Dry air may allow it to travel a bit more quickly. But overall, incense is designed to burn steadily. Many sticks move at roughly 1 to 2 centimeters per minute. This predictable pace is part of what makes incense feel measured. You can glance at the stick and estimate how much time has passed by how much remains. The ember becomes a quiet clock, not digital, not ticking, but visible. The glowing point marks the present moment. The ash above marks what has already happened. The unburned portion below marks what is yet to come. As the ember advances, fresh material reaches the heat zone. New scent molecules are released. The cycle repeats. Heat loosens compounds. Compounds rise. Air carries them outward. Because the burn is slow, the release of scent is also gradual. There are no sudden bursts of fragrance. The room changes in layers rather than waves. This steadiness influences perception. A rapid change in scent might draw sharp attention. A slow, continuous change feels less urgent. The nervous system does not need to react quickly. Instead, it can adjust smoothly. Watching the ember travel can also shift awareness toward time in a different way. Instead of checking a clock or counting minutes, you observe a physical process unfolding at its own pace. The movement is too slow to rush. You cannot make it burn faster by watching it. You cannot pause it without extinguishing it. It follows its own rhythm, shaped by oxygen flow and material density. That rhythm can gently invite your own pace to match it. Breathing slows to the speed of the rising smoke. Thoughts stretch between inhalations. The room settles into a steady state. When the incense finally reaches its base, the ember fades. The glow dims from orange to red to grey. Heat dissipates into the air. The process ends as quietly as it began, from spark to ember, from ember to ash. And in that slow progression, time has passed not through numbers on a screen, but through visible transformation. A simple chemical reaction, a controlled supply of oxygen, a steady descent. The science is precise. The experience is gradual. And in that gradual unfolding, the pace of the room seems to soften alongside it. Above the ember, the smoke continues to move. At first glance, it may seem random. A thin ribbon rises straight upward, then bends, then curls, then dissolves. No two moments look exactly the same. And yet, the motion does not feel chaotic. There is a reason for that. Smoke follows the rules of fluid motion. Warm air is lighter than cool air. As the ember heats the air around it, that warmer air rises. Cooler air from the surrounding room moves in to replace it. Where these two streams meet, small differences in speed create rolling shapes called vortices. A vortex is simply a swirling pattern that forms when layers of air move past one another at different speeds. These patterns are natural and predictable in their behavior, even though their exact shapes are never repeated. You see similar motion in clouds drifting across the sky, in steam rising from tea, in water flowing around a stone in a stream. The shapes change constantly, but they change smoothly. This smoothness matters. The human visual system evolved to track movement in the environment. Sudden, sharp changes often signal something important. A quick flash or a rapid shift draws attention because it could indicate danger. Smoke does not move that way. Its curves are gradual. Its shifts are soft. Even when it twists into a tight spiral, it unfolds gently. Because the motion is continuous rather than abrupt, the brain does not interpret it as a threat. Instead, it categorizes it as safe. There is a term sometimes used in psychology to describe a tension that is held without effort. It is called soft fascination. Soft fascination happens when something is interesting enough to watch, but not demanding enough to drain mental energy. Watching ocean waves, observing leaves move in wind, following clouds drift. Smoke from incense fits into this category. It changes just enough to remain engaging, but it does not require analysis. There is no task to solve, no outcome to predict. The patterns follow the laws of physics, not intention. Warm air rises. Cooler air folds inward. Tiny currents shape the flow. Your eyes track the movement automatically. Attention narrows slightly, but without strain. Because the motion is never identical, it remains gently novel. Because it is never chaotic, it remains easy to follow. This balance between change and stability is calming for the visual system. If something were completely still, the mind might wander. If something were flashing or unpredictable, the mind might tense. Smoke occupies the middle ground. Fluid, continuous, unhurried. As the ribbon rises, it thins and spreads. Eventually, it becomes invisible, blending into the room. The visual trace fades, but the memory of its movement lingers. Even a brief moment of watching can quiet internal dialogue. Thoughts may slow as attention attaches to the physical world. You do not need to think about why the smoke curves. You do not need to calculate the air currents. You simply observe. The brain recognizes the motion as natural. The same physical rules govern air everywhere. Rising warmth, mixing layers, gradual diffusion. And because those rules are consistent, the motion feels reliable. The ember glows below. The smoke curls above. Light catches the edges of the ribbon before it dissolves. A visual rhythm forms. The movement does not ask anything of you. It does not compete with other stimuli. It unfolds at a pace that matches slow breathing. And in that quiet unfolding, attention finds something to rest on without being pulled tight. Soft fascination does not empty the mind. It lightens it. Just enough for the room to feel steady. Just enough for time to feel unhurried. And just enough for stillness to seem natural rather than forced. As smoke rises and scent spreads, something else begins to change quietly in the body. Breathing. Smell and breath are closely linked. Unlike sight or sound, scent requires inhalation. You cannot detect fragrance without drawing air inward. Because of this, noticeable smells often encourage slightly deeper breaths. It is rarely dramatic. You may not even realize it is happening. But when incense becomes present in a room, inhalation often lengthens just a little. The body draws in air more fully to sample the scent. Exhalation may follow more slowly. This small shift matters. Breathing is connected directly to the nervous system. Specifically, it influences what is called the autonomic nervous system. The autonomic nervous system controls processes you do not consciously manage, such as heart rate, digestion, and pupil size. It has two major branches. One branch prepares the body for action. It increases alertness, raises heart rate, and mobilizes energy. The other branch supports rest and recovery. It slows heart rate, encourages digestion, and allows muscles to soften. Slower, deeper breathing tends to activate the calming branch. When inhalations become steady and exhalations lengthen, signals travel through the vagus nerve, a long nerve that connects the brain to many internal organs. Gentle stimulation of this pathway can reduce heart rate slightly and encourage relaxation. Incense does not directly slow the heart, but by encouraging fuller inhalation and steadier rhythm, it can indirectly support this calming pathway. Breath in, scent detected. Breath out. Each cycle becomes slightly more intentional, even if you are not consciously directing it. The air feels textured with fragrance. You may pause briefly at the top of an inhale, noticing the scent before releasing it. These pauses are subtle forms of regulation. Slower breathing also influences carbon dioxide levels in the blood. When breathing is calm and even, the balance of oxygen and carbon dioxide stabilizes. This balance contributes to a feeling of steadiness in the body. Muscles often respond as well. When breathing is shallow and rapid, muscles tend to hold tension. Shoulders rise, jaw tightens, neck stiffens. When breathing deepens and slows, those muscles may loosen slightly. The changes are incremental. A few beats per minute slower heart rate, a slight drop in muscle tone, a quieter pattern of neural firing. Over time, repeated exposure to these conditions strengthens the association between scent and calm breathing. The nervous system begins to anticipate relaxation when the familiar fragrance appears. This anticipation reduces effort. You do not have to consciously decide to breathe more slowly. The environment encourages it. Some studies have measured changes in heart rate variability during relaxed states. Heart rate variability refers to the subtle variation in time between heartbeats. Higher variability is often associated with a balanced, flexible nervous system. Slow breathing tends to increase heart rate variability gently, reflecting a shift toward calm regulation. Incense may support this shift indirectly through breath. The scent invites inhalation. Inhalation slows. The calming branch of the nervous system engages more fully. At the same time, the steady visual movement of smoke and the predictable burn of the ember reduce external demands on attention. Fewer demands mean less urgency. Less urgency means breathing does not need to stay fast. The room becomes synchronized with the body. The ember glows slowly. Smoke rises in soft curves. Breath follows the same gradual pace. As breathing steadies, awareness may drift inward. The rhythm of air moving in and out becomes more noticeable. The chest expands and falls. The abdomen rises and settles. There is nothing to force, nothing to correct. The body knows how to regulate itself when conditions allow. Incense does not override that process. It simply creates an environment that makes calm breathing easier to find. And when breath steadies, the rest of the body often follows. Heart rate slows slightly, muscles soften, attention grows quieter, all through a simple cycle. Air warmed by ember, molecules carried inward, breath responding in kind. A quiet exchange between environment and physiology, one inhale at a time. As the incense continues its steady burn, the ember traveling slowly down the stick, something subtle begins to shift. Your sense of time. Here is the quiet idea at the center of this section. When the body relaxes, the brain's internal clock slows. Moments begin to feel longer. Without urgency, time stretches. The brain does not measure time with a ticking sound or a tiny clock hidden somewhere inside the skull. Instead, it estimates time based on activity. It watches for change, movement, sensation, thought. Each noticeable shift becomes a small marker. You can think of the internal clock as a system that counts events. When many events happen close together, the brain registers a dense stream of markers. In these states, time can feel fast and tight. There are many updates to process, many signals to organize. In busy environments, the brain tracks constant variation. A notification sound, a shift in light, a movement in the corner of your vision, a new thought forming, a change in temperature. Each change becomes a mental timestamp. More timestamps create a feeling of speed. In calmer environments, fewer changes stand out. Incense helps shape that kind of environment. The scent remains steady, rather than appearing in bursts. The smoke rises in smooth, flowing curves. The ember advances slowly. Breathing deepens. The room feels predictable. Predictability lowers arousal. Alertness plays a powerful role in time perception. When something demands immediate attention, alertness rises. The brain increases the pace of internal signaling. This heightened state supports quick reactions, but it also makes moments feel compressed. When urgency fades, the pace of internal signaling softens. In a space scented with incense, attention often narrows gently toward breath and scent. Fewer sensory inputs compete for priority. The visual system tracks slow smoke instead of rapid change. The auditory system registers fewer sharp interruptions. With fewer distinct events to mark, the internal clock eases its rhythm. Researchers studying relaxation and meditation have observed a similar pattern. In calm states, people often underestimate how much time has passed. A quiet 15 minutes may feel brief when measured later, yet spacious while it unfolds. This effect connects directly to event density. Event density refers to how many noticeable changes occur within a period of time. High density creates a sense of rapid passage. Low density creates a sense of expansion. Incense lowers event density. The ember's movement becomes one of the few visible markers. Its glow shifts gradually from bright orange to softer red. Ash lengthens millimeter by millimeter. These changes happen slowly enough that the mind does not need to segment them sharply. Breathing supports this shift as well. Slower breathing influences neural rhythms. A steady inhale and exhale communicate stability to the brain. Heart rate may decrease slightly. Muscles soften. These physiological signals reinforce a low-demand state. In low-demand states, the brain relaxes its tight measurement of duration. Instead of slicing experience into small units, it allows moments to blend into one another. Breath in, breath out. Smoke rising, scent lingering. Each cycle feels complete. The internal clock responds to this continuity by stretching perception. Seconds feel fuller. A short pause feels open rather than narrow. This does not mean time stops. The physical world continues at the same pace. The clock on the wall moves steadily forward, but internal experience shifts. Without urgency pressing from behind, there is less need to measure precisely. The brain settles into presence rather than anticipation. Even memory reflects this change. When a period contains many sharp events, memory stores numerous distinct markers. When a period is smooth and continuous, memory stores fewer boundaries. Later, that time may feel calm and seamless. Incense contributes to this seamlessness. Stable scent, soft visual motion, predictable burn, steady breath. Together, these elements reduce stimulation and smooth perception. As the ember nears the base of the stick, you may glance at a clock and realize more minutes have passed than expected. The internal clock has been operating at a gentler pace. Moments feel longer while they unfold, yet pass without pressure. Time expands in experience. The glow fades gradually. Ash gathers softly below. The scent thins into the surrounding air, and within that softened atmosphere, duration feels less like something to chase and more like something to inhabit. When the body relaxes, the brain's internal clock slows. Moments open. Calmly, time stretches quietly outward, carried by breath, marked by ember, shaped by the slow drift of smoke through air. As the incense continues to burn, something else begins to form quietly in the background. An association. The brain does more than detect scent. It connects scent to place. Each time you experience a fragrance in a particular room, the brain links those two pieces of information together. The smell becomes part of the location. The location becomes part of the smell. This process is called context memory. Context memory means the brain stores experiences together with their surroundings. It remembers not only what happened, but where it happened and what the environment felt like. Scent is especially powerful in this process. Earlier, we explored how smell connects directly to emotional and memory centers in the brain. Because of that close connection, scent often binds strongly to the setting in which it appears. If you light incense in the same room each evening, over time, the brain links that fragrance to that space. The room begins to carry the scent in memory, even when no smoke is visible. The association grows quietly. Incense burning, soft lighting, slower breathing, stillness. These elements become woven together. Later, when you enter that same room and catch even a faint trace of the fragrance, the brain begins to recreate the pattern. It recalls the calm breathing. It recalls the slowed attention. It recalls the softened pace. The feeling returns more easily. This is context memory in action. The brain does not store experiences as isolated pieces. It stores them as networks: scent, light, temperature, posture, emotion. All of these form a cluster. When one part of the cluster appears again, the others can reactivate. This is why certain places feel different the moment you enter them. A library carries a different atmosphere than a kitchen. A bedroom feels different than a hallway. These differences come from repeated patterns stored in memory. When incense becomes part of that pattern, it strengthens the identity of the space. The room becomes associated with calm. Even after the smoke fades, something lingers. Scent molecules disperse gradually. Some settle into fabrics and wood. Others fade into the air and disappear. But the memory trace remains. You may walk into the room hours later and feel that it carries a softer tone. Even if the fragrance is barely noticeable, the association persists. The brain has marked that location as steady and predictable. Predictability reduces mental rush. It lowers pressure. It signals safety. Because scent binds strongly to emotional memory, it can act as a shortcut back into that state. A faint trace of sandalwood may recall quiet evenings. A hint of resin may recall slower breathing. The effect does not rely on strong intensity. Often, it is subtle. The room feels different even when the visible smoke has long since vanished. Context memory also explains why incense used in different locations creates different impressions. If one scent is burned in a meditation space and another in a workspace, the brain will link them to different patterns of attention. Returning to each scent will gently recreate the associated mindset. The space becomes shaped by repetition. Light, scent, breath, stillness. Over time, these elements define the atmosphere of the room. Incense does not permanently change walls or furniture. It changes the way the brain encodes the space. When the brain encodes a space as calm, entering that space becomes easier. The body shifts more quickly. Breathing steadies sooner. Attention narrows without effort. The smoke may fade within minutes. The glow may dim to ash. But the context remains. Scent marks space quietly, linking chemistry to memory. And in that link, a room becomes more than a room. It becomes a place where calm has happened before, and where calm can happen again. All incense burns. All incense releases scent. But the way it burns, and the way the scent behaves, depends on the material. Different plant materials create different experiences in the air. Resins, woods, and herbs each behave in their own way once heat is introduced. Resins begin as sap. Frankincense and myrrh are examples. The tree produces sticky liquid to protect itself after the bark is cut. That liquid hardens into solid droplets. When heat reaches those hardened pieces, they soften and melt before fully smoking. This melting stage changes how scent is released. Because resins liquefy first, aromatic compounds can evaporate gradually from the surface before higher temperatures break them down. The result is often a rich, layered scent that unfolds slowly. Resins tend to produce thicker smoke than woods. Their scent often feels heavier in the air. Many resin compounds are slightly larger molecules, which means they linger longer once released. Lingering scent creates depth. Even after the visible smoke thins, the fragrance may remain close to surfaces and fabrics. The air feels fuller for a longer period. Woods behave differently. sandalwood, cedar, and other aromatic woods are dense plant structures. Their fragrance is stored within solid fibers rather than hardened sap. When shaped into sticks or chips, wood burns through steady smoldering rather than melting. Because wood does not liquefy first, its scent release is tied directly to the ember's movement. The ember travels gradually down the material, releasing aromatic oils as it goes. This produces a consistent, even scent field. Wood smoke often appears finer and more stable than resin smoke. The scent may feel smoother, with less sharpness. Burn speed also differs. Dense woods burn more slowly because oxygen penetrates their structure gradually. This slower burn creates a steady rhythm. The ember moves predictably. The scent remains balanced. Herbs introduce another variation. Dried leaves and flowers are lighter and more delicate than resin or hardwood. Lavender, sage, and other herbs contain volatile oils stored in small glands within the plant tissue. When heated, these volatile oils release quickly. Herbs tend to burn faster because their structure is less dense. Oxygen moves easily between leaves and stems. The ember can travel more rapidly, and the scent may appear brighter at first. Because many herbal oils are smaller, more volatile molecules, they evaporate quickly and disperse more rapidly in the air. This creates a lighter, fresher scent profile. The air feels clearer. The fragrance may fade sooner compared to resins. Burn speed, scent weight, and linger time all shape perception. Resins melt before smoking, produce thicker, heavier scent, linger longer. Woods smolder steadily, release fragrance gradually, burn at a measured pace. Herbs ignite more easily, release bright, lighter aromas, disperse more quickly. These differences do not mean one material is stronger or better. They simply create different atmospheric textures. A resin can make a room feel grounded and dense. A wood can create a smooth, stable field of scent. An herb can brighten the air with a lighter presence. The brain responds differently to each. Heavier scents may feel anchoring. Lighter scents may feel refreshing. Steady burn speeds create predictable pacing. Faster burns introduce quicker shifts. Even the visual behavior changes. Resins may bubble before smoking. Woods maintain a narrow, glowing ember. Herbs may produce brief flares before settling. Each material follows the same physical principles of combustion and evaporation. Heat releases stored compounds. Air carries them outward. The nose detects molecular patterns. Yet small differences in structure change the entire experience. A room filled with resin smoke feels distinct from one scented with sandalwood. A space brushed with herbal fragrance feels different again. Burn speed influences time perception. Scent weight influences how full the air feels. Linger time shapes how long the atmosphere remains altered. Over centuries, different cultures selected materials based on these qualities. Resins for depth and ceremony. Woods for steady meditation. Herbs for cleansing and brightness. The chemistry varies. The physics varies slightly, but the outcome remains similar. Heat transforms plant material into airborne molecules. Those molecules move through the room. They bind to receptors. They shape attention. different materials create different textures of calm. And in that variation, incense reveals how small structural differences in nature can influence how a space feels, slowly, steadily, and in layers carried on air. Long before incense became something small and affordable on a shelf, it was rare. Not rare in mystery, rare in geography. Many of the most desired incense materials came from specific trees that grew only in particular climates. Frankincense trees thrived in dry, rocky regions of the Arabian Peninsula and parts of East Africa. Myrrh grew in similar arid landscapes. Sandalwood developed slowly in certain parts of India and Southeast Asia. These trees did not grow everywhere. That alone made their resin and wood uncommon in distant regions. To obtain them, people had to travel. Resin hardened on bark under desert sun. Wood matured over decades in forest heat. Harvesters carefully collected these materials by hand. The process took time. Once gathered, the materials had to move. Long trade journeys carried incense across deserts and along sea routes. Caravans crossed arid landscapes, transporting small bundles of resin that held enormous value relative to their size. Ships carried fragrant wood across oceans to ports, where it would be weighed, sold, and divided. These journeys could take months. During travel, materials had to remain protected from moisture, damage, and theft. The further incense traveled from its source, the more valuable it became. Scarcity increases perceived importance. When something is difficult to obtain, people assign it greater meaning. The rarity itself becomes part of its identity. Incense gained status because it came from far away. But its value was not only practical, it was symbolic. Temples burned incense as part of ceremonies. The rising smoke represented offering, transition, and reverence. In religious settings, fragrance filled large stone rooms, changing the atmosphere in ways that felt deliberate and purposeful. Because incense was scarce and costly, it was often reserved for meaningful occasions. Daily life might pass without it. Special rituals would include it. This selective use strengthened its importance. When a material appears only during significant moments, the brain associates it with meaning. The scent becomes linked to ceremony, gathering, or sacred time. Incense was also valued because of its effect on space. Before modern lighting and climate control, scent played a major role in shaping indoor environments. Fragrance could soften the smell of crowded rooms or enclosed buildings. It could mark the beginning of prayer or signal the closing of a day. In some cultures, incense even functioned as a timekeeper. Carefully formed coils burned for hours at a predictable pace. The length of ash marked duration. The glowing ember became a quiet measure of time. The fact that incense could both change atmosphere and measure time increased its usefulness. Yet at its core, its value always returned to scarcity. Rare trees, limited supply, long journeys, careful harvesting. When something rare becomes part of ritual, it gains depth. Even small amounts felt significant. A handful of resin placed on charcoal could transform an entire hall. A single carved stick of sandalwood could release fragrance for an hour. The materials were light, portable, and powerful in effect. Trade routes formed around this demand. Caravans moving incense connected distant regions economically and culturally. Ideas and goods traveled alongside resin and wood, Incense became one thread in a larger network of exchange. Over time, cultivation improved. Trade stabilized. Materials became more accessible. What was once reserved for temples slowly entered homes. Yet the memory of its rarity remains in cultural tradition. Even today, incense often appears during moments of intention, meditation, prayer, reflection, or transition. The physics have not changed. Heat releases aromatic molecules. Air carries them outward. The brain responds. What has changed is access. What once required months of travel now rests on a shelf. Yet the sense of value lingers because of history. Scarcity once amplified importance. Importance reinforced ritual. Ritual strengthened memory. And memory continues to shape perception. When you light incense today, the ember connects quietly to that long chain of geography, trade, and ceremony. From tree to caravan, from caravan to temple, from temple to home. The material itself carries a story of distance and effort. And even though it is now widely available, its history adds weight. A small glowing tip in a quiet room carries traces of rare trees, long journeys, and centuries of use. Scarcity shaped its value. Value shaped its meaning. And meaning continues to drift upward with the smoke. By now, the ember has almost reached the end. Ash gathers softly below. The scent has settled into the room. The smoke rises in thinner ribbons than before. And what remains is a simple question. Why do we still burn incense today? The answer does not rest in mystery. It rests in physics, chemistry, memory, breathing, ritual, and attention. Physics begins the process. Heat meets plant material. Oxygen reaches the glowing tip gradually. The material smolders rather than flares. The ember moves at a steady pace. Smoke rises because warm air lifts upward through cooler air. These are natural rules. The same rules that shape clouds and steam shape incense smoke. Chemistry follows. Within resin, wood, or herb are aromatic compounds stored in solid form. Heat loosens those compounds. They become airborne molecules. Each molecule carries a particular structure. Each structure fits specific receptors inside the nose. Signals travel from those receptors into the brain. Memory receives those signals. Scent connects directly to emotional centers. The brain links fragrance with place, with lighting, with posture, with mood. Over time, a particular scent becomes tied to a particular state. Lighting incense in the evening teaches the brain what evening feels like. Returning to that scent later recreates the pattern. Breathing shifts in response. Scent encourages fuller inhalation. Fuller inhalation activates calming pathways in the nervous system. Heart rate slows slightly. Muscles loosen. The body adjusts toward steadiness. Ritual strengthens the sequence. The hand reaches for the stick. A match flares briefly. The flame disappears. The ember glows. Repetition teaches predictability. Predictability reduces pressure. Reduced pressure softens the pace of internal signaling. Attention narrows gently. The smoke provides soft visual movement. The scent provides a stable sensory anchor. The ember provides a slow measure of time. With fewer competing signals, mental speed decreases. Thoughts spread out rather than cluster tightly. The internal clock eases its rhythm. Moments feel broader. All of these processes are small. No single step forces calm. Instead, calm emerges from layers. Heat releasing molecules, molecules shaping perception. Perception guiding breath. Breath influencing physiology. Physiology adjusting time perception. Memory marking space. This layered sequence explains why incense continues to appear across cultures and centuries. It changes atmosphere without demanding effort. It marks transition without loud signals. It slows attention without force. Even in modern environments filled with screens and constant updates, incense offers something steady. A single glowing point. A visible progression from stick to ash. A scent that remains consistent rather than flashing. The tools have changed over time. Electricity lights rooms. Digital clocks measure seconds precisely. Air systems regulate temperature. Yet incense persists because it engages older systems in the body. Smell, breath, memory, pattern recognition. These systems operate quietly beneath conscious thought. When incense activates them together, the effect feels integrated. The space changes, the body changes, time changes, and all of it arises from simple interactions between matter and air. We still burn incense because the human nervous system remains sensitive to its process. We still respond to predictable rhythm. We still settle when sensory input becomes steady. We still form associations between scent and place. The ember nearing its end reflects this continuity. It glows the same way it did centuries ago. Heat meets resin. Smoke rises. The brain responds. Physics remains constant. Chemistry remains constant. The structure of memory remains constant. Breathing continues its quiet exchange with air, and so incense remains, a small, controlled fire that reshapes atmosphere through layers of interaction. A simple material, a steady burn, a slow transformation, and a reminder that calm can arise from the smallest visible change in a room. The ember reaches its final point. The glow softens from orange to red, from red to grey. The ash at the tip grows fragile and light. Eventually, the heat quiets completely. No flame, no movement. Only a thin column of cooling air where smoke once rose. The scent remains for a while. Scent molecules continue drifting through the room, though in lower concentration now. Some settle into fabric. Some cling briefly to wood. Others disperse gradually into the surrounding air. And then something interesting happens. Your nose begins to stop noticing it. This is called sensory adaptation. Sensory adaptation means your receptors become less responsive to a constant stimulus. When a scent stays steady for long enough, the olfactory receptors in the nose reduce their signaling. The brain stops treating the fragrance as new information. The scent may still be present, but it feels lighter, less vivid, less defined. This does not mean the incense has disappeared completely. It means your sensory system has adjusted. The brain prioritizes change. When something remains stable, it fades into the background of awareness. The smoke disperses according to simple physical rules. Warmer air cools. Air currents carry particles outward. Concentration lowers with time and space. What was once visible becomes invisible. What was once strong becomes faint. And yet, something often remains. Breathing may still be slower than before. Shoulders may still feel softer. Attention may still be narrowed gently inward. The calm state can persist beyond the scent itself. Earlier, we explored how scent marks space and builds context memory. We explored how slower breathing influences the nervous system. We explored how steady visual motion softens mental speed and how the internal clock eases its pace. Those shifts do not vanish the moment the ember goes dark. The nervous system does not reset instantly. It carries momentum. If breathing slowed for 20 minutes, it may continue at that pace. If attention narrowed gently, it may remain less scattered. If the room has been encoded in memory as calm, that association continues even without active smoke. The air clears, the particles disperse, receptors adapt, but the body remembers the pattern. A room that held steady scent and soft light now holds quiet air and dim glow. The transition from presence to absence is gradual. No sharp ending, just thinning, just cooling, just settling. This final stage mirrors the beginning. A match flared briefly. A flame touched the tip. Smoke rose, scent spread. Breathing shifted. Time softened. Now the ember fades. The scent lightens. The room returns to stillness. And in that stillness, there is no need for continuation. The process has completed itself. Incense began as solid plant material shaped by heat and air. It transformed into airborne molecules. Those molecules shaped perception, breath, memory, and attention. Then they dispersed. The calm that arose from that layered interaction does not require constant reinforcement. It can remain quietly in the body. The room feels subtly altered, even if the air has returned to its neutral state. The ash rests below, fragile and pale. A small trace of transformation remains on the holder, and the space holds the memory of steady breath, soft fascination, and expanded time. The scent fades, the smoke clears, the nervous system settles into its own rhythm, and the room returns to quiet, shaped for a while by heat, chemistry, and attention, now resting in simple air once more.